Welcome to the Advanced Detailing with SOLIDWORKS MBD webinar. My name is Gordon Purcell with Decide Solutions, broadcasting out of Phoenix, Arizona. In the next 30 minutes, we want to talk about some of the latest advancements in SOLIDWORKS MBD and SOLIDWORKS DimXpert that's really going to help you, kind of push out the design information and improve communication of that design with manufacturing. As we hope you see from the webinar, using SOLIDWORKS MBD and DimXpert is really going to guide this design to manufacturing process directly inside of 3D. We could essentially, this is going to be a much more efficient process as opposed to creating 3D designs and then translating everything into a 2D design or a flat paper drawing. With this, essentially, we're going to be able to reduce a lot of the time mistakes associating with creating those 2D drawings by keeping everything natively in 3D. I have a roadmap up top here. We're going to go through this today, starting with just an overview, an introduction to DimXpert, and then go through the step where we actually define the product manufacturing, PMI, and then we organize that PMI so that it can be delivered to manufacturing, and then the actual steps where we publish that product manufacturing information into a 3D PDF format. Let's get started with the introduction. In the next couple of minutes, I'm going to go through an overview of what DimXpert is, some use cases and exceptions and best practices, and a little bit about some of the newer technology in 2017. So what DimXpert is it's basically, as on the screen, a lot of times as we're creating 3D models and sketches, we provide information for modeling that, but it's not necessarily the same dimensions or tolerances that we require for manufacturing operations. What DimXpert does is it basically is that tool that allows us to create the standardized dimensions for ASME Y1441 for manufacturing. There's a toolbar inside of on top of SOLIDWORKS where the DimXpert tools are available. As you can see, there's an auto dimension and manual dimensions. How the technology works is it really looks at the topology or the surfaces of the model and the edges of the model and recognizes those as features such as fillets, chamfers. It can also take groups of fillets or groups of features and recognize those as patterns. To give you, specifically the tools or identify the features that you need for your requirements, there's also a feature selector. Whenever we select something inside of DimXpert, we can define that feature as a plane or maybe as a fillet or a cylinder or a conic or that type of thing. In this example over here, maybe rather than getting a horizontal dimension, we want to have a straight line point to point or a theoretical sharp corner. So in that case, we can select face sets and create intersection lines. And likewise down here on this drafted or injection molded part, we typically want to have a theoretical sharp corner where a plane and the conic intersect and then provide the draft angle. On more complicated parts or the simple parts as well, typically how do we arrange these dimensions? We arrange those in annotation views. Those keep the dimensions square and flat to the screen and all of our orthogonal views. Getting into the next step in the first part of the product demonstration, we're going to review DimXpert templates and how to use this feature selector to specify, and then also, we're going to go through a couple dimensioning modes. I'm going to show an auto dimensions mode and a manual dimension mode to define your product manufacturing information. Let's jump over to SOLIDWORKS. First thing we're going to look at is the templates. On the document properties, we have a DimXpert area. This first one here is we can select a radial option to define the type of tolerance we want to use for dimensions that do not have a tolerance. Here we can define the type of tolerance. For example, if we select a holder dimension, do we want it to default to use a symmetrical tolerance, a general tolerance, or bilateral tolerance? Again, it's just going to kind of speed things up. You have a company standard based on this template that everybody conform to with a default tolerance for those types of features. Same thing with location. The chain dimension for holes here, whether we want to use a chain dimensioning style or a baseline dimensioning style. Same thing with pockets as well. Again, the help file gives you a little bit better idea of how these apply. And here's an example of using chain, and here's an example of baseline. For the GD&T specifically, do we want to use mass material condition at the datums or at the position? And what should the primary, tertiary, secondary, tertiary tolerances be? Those that can all be defined in this template. Do we want to recognize angular faces as chamfers? We have a width ratio and a max chamfer size here. And then tolerance settings for distance and angular dimensions. How do you want those dimensions to look and feel? For an example, do you want the traditional hole call out, or do you want to have your more traditional drafting standard type of dimensioning scheme? Let's start with the auto dimensioning scheme. And let's note here that we can typically define things that are prismatic with milled or turned. We can select a scheme, which is plus or minus or GD&T. In this case, I'm going to use a GD&T and linear scheme and define my first datum set. Now this first datum is recognized as a plane, so it recognizes that as one continuous planar face. The next thing I want to do is use a width mate. So I'm going to use my feature selector here to grab a width mate. What it'll do is it'll find the center of those two faces for the datum. Let's continue on with our tertiary. Again, we'll use not a plane, we'll use the width mate or width feature. You can see they're highlighted, and that means those datums are applied. Down here in the scope of what we want to dimension, we can have it just go through and automatically recognize all these features. Me personally, I like to have a little bit more manual control, so I'll use selected features. Notice I can pick a fillet. It's recognized as a fillet. If I select the side face here, it actually gets recognized as a pocket, and we'll put a surface profile dimension on there. So we'll just continue with selecting. Again, we can recognize this as a slot or a pattern of slots so that we get the correct instance count. Moving on, we want to select this hole. Again, it could be a hole or a pattern of holes. Likewise, we'll grab this pattern of holes. We'll grab our fillet, and that's recognized as a fillet, and the back side of the face will be a plane. We'll go ahead and hit OK, and looks pretty good. So SOLIDWORKS, basically what it does is this show tolerance status. It lets us know which faces and edges are, really the faces, are fully defined, provide the full definition. So what's left here, you can see when I use the width mate, essentially it applied datum C at the middle of this 4-inch dimension. What I typically do here is I spend a little bit of time cleaning things up. Just to note, you can place dimensions, you can move them around, attach them to different edges or faces to your liking. Maybe we want to move this guy up here. So you have lots of freedom and liberty there, as well as you have all the same dimensional properties over here that you would in a traditional 2D drawing. Notice I have the instant count for the slots and the holes. Everything looks good, and for the true position for these dowel holes through here. One other thing we might want to do is we might want to add the basic dimensions, right? So anything here that has a true position may or may not have a basic dimension. There's a couple ways to do that. You can right-click and just create those basic dimensions with the correct instance count, or what you can do is just manually create traditional dimensions or basic location dimensions. So let's go ahead and add our basic dimension there, and we'll add another basic dimension over here. You can move these guys around. If you want to have the instance count on here, it's just another dimension, right? So you have full control to add notes in here. So very commonly we might have something like 4 or 2 times, whichever. Definitely not 5, or definitely not $sign and X. Okay. So that completes the first step, which is defining the PMI. We went through and we showed you how to use some of the templates, as well as reviewing the feature selector, which really what that does is it helps us capture speed up the process as we capture all of our product manufacturing requirements. And we use the auto dimension tool to really, again, that just improves the overall detailing process. It helps us define all the product manufacturing information and dimensional characteristics per the standard ASME 1441. Moving on to the next section, let's talk about how we stay organized with all these 3D annotations on our model. We're going to talk about annotation views and scaling the annotation views, some newer technology, which is the dynamic annotation views, which basically as the orientation of the view comes into proximity of the screen, the appropriate dimensions will turn opaque or translucent. And then starting to get organized to deliver our information into a 3D PDF. We'll talk a little bit about the 3D views. So the first thing is I want to talk about here is let's talk about the dimension scale. If we right click on the annotations folder over here, we can see the details. And what we can do is we can see a scale. Depending on the size of the document, you may want that on or off. Right with that off, it's going to use the size of the font associated with document properties. Now, some of these other dimensions here, right? What we can do with these essentially is if I take this guy here, which is my flatness for datum A, and hit the tilde key, what I can do is you can see that I can change the orientation of this dimension to the screen. And what I'm doing here is I'm selecting the top, which is the top annotation view, and then I can kind of drag this around to where I think it is best viewed. With this guy here, I could do the same thing with this profile dimension for this pocket. Essentially, if I want to show that in the top view, then I can move it to the top view. So you have full flexibility of how you want to arrange these within these annotation views. So let's talk more about that. Over here on the left-hand side, whenever we use the auto dimension scheme, it will automatically create these annotation views to place the dimensions, and these typically match your standard views. So if I right-click and activate and orient the top view, it orients the model to the top view, and will hide any other annotations, or only show the annotations associated with that top view when all annotations are hidden. So now when I rotate it, I only see the dimensions in that view. Likewise, if I go to double-click on another view to activate it, hide those. Okay, so if we go to the front view, we can see that this dimension, which is the material thickness, is associated with the front view. So we really don't need the bottom and the right view at this point. But I want to jump back to, I want to show the top view annotations for just a minute. And then I want to activate another annotation view that I set up, which is really going to be used to explicitly show the information for the tap tools. So let's go ahead and hit our tilde key here and move this guy over to the tap tools. Likewise with this guy. All right, so now I have a view that's specifically here for my tap views for the linear dimension as well as the horizontal dimension. Let's jump back over to here. So that's the annotation views. The other thing that's nice is if you do have all these dimensions shown, what you can do is enable dynamic annotations here, and you can see what it does is it hides dimensions when that annotation view is not normal to the screen. So that can be kind of just a handy way to kind of look at the model and not have too much clutter on the screen. Now, as we get ready to go to manufacturing or deliver this document to manufacturing, we're typically going to deliver that into PDF, but we could also push that out as an e-drawings or directly as its step AP242. In this case, I'm going to push this out as a PDF. What I'm going to do is leverage these SOLIDWORKS MBD 3D views down here. Before we jump into that, let's create an area for our notes. We'll go to our notes folder, insert a notes area. What we can do is we can hide our dimensions, right? And what we can do is add a note. And let's say we want to add a general notes area here. we'll use some bullets. We'll make everything nice and bold, and maybe make it a little bit bigger. Okay, and we'll say plate. And then another one might be general linear dimension tolerances. And here's where I can reference back to the general tolerance block that I was talking to earlier about with inside the DimXpert template. So what I'm going to do is just go ahead and reference my general linear tolerances here as a custom property, and that'll show right up on the note. So if I change it back in my template, my document properties, it updates there on my note as well. That's linked to this guy here for length tolerances. Let's make everything bold. And everything big. Great. Put that over there. And again, so now we have a notes area for that. And then the next step is to use these 3D views. So we'll capture this as a 3D view, and notice here that I can pick and choose which annotation views that I want to place inside this 3D view. And I'm going to call this the notes area. I'm just going to use the same name. Next, I'm going to go and activate my top view and hide my notes area. Let's also orientate this so it's normal to the screen. We'll capture our next 3D view and only capture the top annotation view. Notice that I could include other annotation views or the annotations from other views here, but I'm only going to include the top. And moving on to the front. Now let's do our tap tools next. And lastly, we'll make sure that we give it the plate thickness as well. And we're on our way. So what we were just looking at is, how do we organize the product manufacturing information or dimensions in a way that can be easily delivered out to manufacturing so that they can utilize and consume this information. We also looked at the dynamic annotation views. That just makes it a much easier way to kind of get the view into the proper orientation without having too much clutter on the screen. And then once we get our annotation views all set up, we're going to go through and basically create 3D views with SOLIDWORKS MBD to capture all that product information, manufacturing information in a format that'll be delivered to the 3D PDF. Let's move on to the next step, which is actually publishing the product manufacturing information. In this step, we're going to export this out as a 3D PDF that can be viewed by anybody that has Adobe Reader installed. We're going to leverage information inside of SOLIDWORKS, such as custom properties information, such as revisions, materials, comments, whichever, and include that inside of the PDF as notes. We're also going to have SOLIDWORKS export a step AP242 file and include that inside the PDF attachment to give us a complete document package. So to get started, if we have our formats, we're going to stick with the 3D PDF, and we can pick from a broad range of templates. As well as SOLIDWORKS provides a really rich 3D PDF template editor so that you can kind of create your own look and feel in standard formats. Over here, I'm going to select the views that I would like to include, which will be the notes, the top tools, and the front. Down below, for the independent view, I'm going to say, let's give it the notes area. Okay, great. And then for attachments, if I wanted to attach a word or some material specifications, something like that, I could go ahead and grab it. I'm also going to include for it to output and create that step AP242, as well as embed it inside that 3D PDF. Let's walk through the wizard and go to the next. Like I said, we can reuse some of the custom properties data and publish that directly into the PDF. Here we'll grab our part number. We already got our revision. Material. And we can add a comment. So some multiple ways to add information into the PDF here. And that completes the wizard. We'll go ahead and hit OK and overwrite this. Let's go ahead and overwrite this file that I had open. So that gives us a really rich 3D to 3D experience. I can open up this inside of Adobe Reader, look at the 3D document. You can see that I have all the same information that's come across with the part number and comments. It's basically transferring all that information that's already in 3D, already in SOLIDWORKS, into Adobe Reader that everybody has that they can use to view and look at your product information. And Adobe Reader, for anything, if you're only dimension critical to function dimensions, and just building the rest of the part to the 3D model, Adobe Reader has all the tools in here to go through and measure the 3D model as well. So let's kind of wrap things up. What we saw here is with SOLIDWORKS MBD, we went from 3D to 3D. We're able to export this to the industry standard 3D PDF, Adobe Reader. There's no data translation really required there. Adobe Reader is installed everywhere. It's pretty much the standard. And we're also to embed and link files, or link our properties to the SOLIDWORKS file, as well as link and embed the step AP242. We just jump back to over here. We can see that here's our step file that's embedded and readily available to be downloaded and imported into a CAD or a CAM system. Again, my name is Gordon Purcell with Decide Solutions. I want to thank you for attending our Advanced Detailing with SOLIDWORKS MBD webinar. Have a good day.